Hi, guys. Today I want to discuss my theory on where warm water halts. I'm going to discuss this based around temperature as a cause for the warm waters halting. Of course, many ways that warm waters can halt, but if we base it on temperature alone, I think it simply halts when it freezes. But this is not really speculation, opinion, or a guess. It is actually a scientific fact. So, due to temperature alone, warm water halt cannot possibly be a hot spring. Now, hear me out. Of course, the risk is that forests may not be basing a halt on temperature. For example, warm waters might halt in a bathtub so long as a stopper is in. That is a physical halt. Tears, when you stop crying, warm water just halted again. But that is also physical, not temperature. I know there's many ways, but for now, I'm going to focus on temperature. So here, I have a video that I'm not going to play back, but I'll link it below. It's at the Teacher's Pet channel, where they display in terms that even a child would understand, and they even use the term halt. But they basically explain the process that I'm talking about in layman's terms. In scientific terms, the term halt is used when water goes from a liquid to a solid state. It is only defined when it goes from a liquid to a solid, not when it goes from a liquid to a vapor. If you go here, I'm going to leave this link too. There is, it's pretty deep. This is the scientific reasoning. And basically they say, at the melting point, the temperature holds steady at the melting temperature until all the liquid has been converted to a solid. This is called a halt. And that's at a paper from the University of Arizona. But that's only one place you'll find the information. And the part that I just read is right here. At the melting point, the temperature holds steady at that melting temperature until all the liquid is converted to a solid. This is called a halt. Okay? So this is the only place, this is the only place that I can find halt actually defined and proven in scientific documents to be that instant in time, that literal point in time when it becomes frozen. After that, it's no longer a halt. Okay? So before anybody says that it's too complicated, it really isn't. As I said, the halt is pretty much the exact time when liquid goes to a solid. That's exactly how creeks and streams form headwaters for major rivers in the Rocky Mountains. Halt might have nothing to do with water boiling into a vapor or gas. It just doesn't work that way scientifically. The key word in that stanza is halt. The adjective warm is simply indicating that the water is neutral or comfortable. It's not frozen and it's not boiling. So we need to find a location where it changes from a liquid to a solid. Now, in Too Far to Walk, Forrest told us about him bathing in Yellowstone on the Firehole River. And he describes how he had to move closer towards the heat of the geyser output and, position himself exactly between the cold waters and the hot waters to find a comfortable position. What Forrest is describing there is called equilibrium temperature. In The Thrill of the Chase, he also explained the same things with the students touching the cold bronze. Until their finger adjusted to the equilibrium temperature, the heat of their body was warming the cold statue until the temperatures became the same. I don't know if you've ever been swimming in a pool or an ocean, but if you talk to a child or anybody, they go in the water and they're usually like, wow, this is cold. And then when you come back a few minutes later, they said, oh, I got used to it. In reality, what really happened is they are at equilibrium with the water. So if you take it another step further, you'll also discover that the oxygen and hydrogen molecules in the water are at a 109-degree angle between each other when it starts to form a lattice as it turns solid. Interesting enough, when you follow the 109th longitude down, you'll notice that from 109 to 110 encapsulates the largest active glaciers in the lower 48 Rockies. Two specifically are the Gannett and the Dinwoodie. It also encompasses the second largest snow-capped mountain, which is Gannett Peak. The largest mountain is actually in Colorado in the Rockies, but the largest active glaciers and snow-capped peak is the second largest, is Gannett in Wyoming. The actual coldest place in the Rockies is in Montana, but that does not have any glaciers there and that are as large as this glacier. And also, it's in the middle of the wilderness where people don't go. The area I'm talking about, people actually live. For example, in Moran, Wyoming, people live there. And the coldest recorded temperatures in all of the Rockies were actually in Moran. I should say the coldest place where temperatures were recorded that people live. Because as I said, it's not the coldest spot in the Rockies, but people don't live in Montana at that coldest spot. And the waters, of course, when they come down from their source, they warm as they get down in the canyon. They don't halt there. They halt at the source, just like at a faucet at a sink. You turn off the faucet, the water's halt. Heat always transfers to the cold first. It doesn't go the other way around. Cold water doesn't cool down the hot water. The hot water molecules move in because they're moving faster. They move in and they melt the snow. But if well, without getting into the scientific stuff, basically what happens is the cold of the snowpack and the ice and the area and the high altitude overrides the heat and forces the warm waters to freeze, which is where they would halt. And they're halted temporarily at that position. They don't, when they melt, they pick up right where they left off. When you look at a geyser or a hot spring, the water changes state to a vapor because it speeds up so much. The molecules, the friction causes it to eventually boil, and then it turns into a vapor. The vapor floats away, goes up into the atmosphere, and eventually rains back down on us, right? That's the cycle of water. But the thing is, it didn't halt. It vaporized. It's gone, right? And it's going to come back down somewhere else. So I've just shown you that scientifically, a halt is defined when the water goes from a liquid to a solid. That is the only time it's defined. And it makes sense because the molecules spread apart till they hit a 109-degree angle at the freezing point. At that point, it turns into a lattice, and the molecules slow down to a point that they're in a halted state. If you examine them with a really powerful microscope, you would see that they're still moving. They vibrate, but they don't move in position. They stay where they are. That's completely the opposite of what happens in hot water. Now, recently, Forrest, on Jenny's website, he posted a story that's similar to what he has in the Thrill of the Chase about their 1,600-mile trip to Wyoming. But this time he put something interesting in there. He put in a discussion about the canvas water bag that they would hang on the front of their car. And they would stop at deserts like Hell's Half Acre, and they would basically get a drink of cold water there as they took their break. Well, that's the same principle again. The water's cooling down because of the wind in the front of the car, which is why radiators are in the front of the car, and also from evaporation. So we're describing the exact principle of what made that water in their water bag cold. He was causing warm waters to approach a halt. Could he be hinting at that? I don't know. But the water is colder where it begins, and it warms on its way down in the canyon, which takes it further and further from being able to halt. Even in a lake, it doesn't halt. Only the surface does. Unless the lake froze solid, then it would. But only, again, above canyons at high altitude. Point blank, the colder water gets, the closer we are to the halt point. The warmer we get, the further we are from a halt. In layman's terms, kinetic energy and why waters halt when frozen because atoms slowing down is pretty much one of the definitions I think that we have here. Now, I'm going to leave a link to a couple of videos. As I said, I got the first one that explains it to a kid, and they even use the word halt here. Then I have another website here that explains the same principle and shows you examples. And then here's another one that shows you with a dye. And you can see that when a dye is placed in the cold water, it comes to a halt, whereas it dissipates in the hot water because the molecules are moving fast and pushing the red dye around. The blue dye is not being pushed around. It's being clumped together because essentially the cold water is slowing the molecules down. And then I have the same thing again here, which is another child's video that shows the 3 states of water, and they explain the same thing. So is this where warm waters halt? I don't know. Honestly, this is where I shouldn't say where. This is what I think he means by warm waters halt. I think we are looking for a headwater, and we are looking at snow-capped mountains, basically. And for example, although I'm not doing this, if you look at the Green River, the Green Water halts by the largest glacier, the largest active glacier in the Rocky Mountains in Wyoming. Okay, and it's right next to Gannett Peak. It's also at 10,200 feet, which is our upper altitude parameter, which is interesting, right? Now, if you were to follow that river down, where does it go? Well, it goes into Arizona. It goes into the Grand Canyon. If you ask anybody in the United States to name a canyon, they're going to know that they're probably going to mention the Grand Canyon. That's the most well-known canyon. All rivers go into a canyon. All of them, at some point, are going to go into a canyon. We need to find a unique one. Well, there is one unique, right? And they're also probably going to know that the Colorado River is inside the Grand Canyon. However, if you follow the Colorado River to its sources, it is glacier fed, but those are not the highest peaks, nor are they the biggest glaciers. There's nothing really special about it. But if we follow the Green River, which is the main tributary to the Colorado River, up to its source, it is at a major unique location based on this warm water halt theory that I'm providing to you here. Is it right? I don't know, but it's definitely simple when you look at it in terms of that. We're starting at the coldest location at 10,200 feet where the Green River is, and it goes down to the canyon. But you got to read that entire stanza. It says, begin at where warm waters halt and take it in the canyon down. Not far, but too far to walk. There's no pause after the word halt. And we have a conjunction, and. So, and is joining the two verbs halt and take. It is saying that begin it. So let's assume it is a river. Begin the river where warm waters halt and take the river in the canyon down. Now, the canyon is not far, but it's too far to walk. Well, clearly, the Grand Canyon is going to be too far to walk. That's just one example. There are other examples. But the point is, I don't believe the poem is telling you to go where the water goes. He is telling you to put in at the home of Brown. Now, the home of Brown might be in completely the opposite direction. The whole point of warm waters halt was to get you to the appropriate area. And then the home of Brown would become obvious, right? Because we can also say that suppose we're talking about the Poposia River. Now, the Poposia River eventually meets at a confluence with the Rin River, okay? But it goes through, the Poposia River goes through a canyon. It goes through Sinks Canyon first. But that one is not far from the headwaters, right? So maybe when he says not far, but too far to walk, he's saying skip the first canyon and go to the second canyon. Well, the second canyon would be the Wind River Canyon, which is where the Wind River goes, just south of Thermopolis. You know, so those are just examples of how that may work. But the point is, the takeaway here is that I think, maybe we shouldn't be focused on hot springs and geysers. I think that's wrong. And there are many confluences that are similar to the Madison Junction, although it fits because two rivers, the Gibbon and the Firehole, are both coming from the geyser basins. They're still cold rivers. Don't get me, they're not warm by any. Go in them and you'll see for yourself. The Madison is not warm either, but the waters do halt and they form the Madison. So the poem, it could mean begin it where those warm waters halted, and it is the Madison, and take it into kind of down. But we've been looking for almost 8 years now, so maybe we're looking at the wrong thing. And as I said, you could search for the term halt, and you're not going to find it anywhere, especially not in any fishing documents. But you will find it in scientific documents, and it makes sense. And regarding 109, if you look at Teachers with Ropes, and I'm not going to get into the details here, but the poem actually sends me there. But if you look at the kids holding a rope, that rope could represent a straightened out line of latitude. And when you have a latitude line going around the Earth, it has intersection points where the longitude lines cross over. Now, you notice on page 109, could that be a hint, again, to the 109th longitude? Okay, so you look down there, and as I said, from 109 to 110 and 42 to 43 latitude pretty much encompasses the biggest glaciers that we have. And they are not in Glacier National Park. They're in Wyoming. There are glaciers in Colorado, but they are not the largest active. And I think it's even debatable that any of them are even considered active glaciers at this point. But I'm no expert. But it is a fact that the ones in Wyoming are active, at least for now. So anyway, be sure to hit that like button and subscribe if you like this. It'll make me do more videos if I know people are interested. And I hope you enjoyed this video. Leave your comments below. And thanks again. Have a great day. Bye.